Let's start. I'm Puya. I'm your host for this afternoon. The next talk is going to be about reproducible development and deployment environments with Bazel and Telepresence. After the talk, there's going to be a Q&A. So if you're leaving behind before that, please leave without too much noise, because people will be wanting to asking questions, and we want to respect the host. Roggia from Engel and Völkers is going to give this talk. Stage is all yours.
Thank you. So, welcome everybody. Today's topic of this presentation is going to be reproducible development and deployment with Bazel and Telepresence. So, before we start, I will just give a short introduction of myself. My name is Roggia. I'm a software developer for Völkers technology, and our mission is to disrupt the real estate market with new technologies. So I'm also currently the maintainer of two different official Helm charts, Logstash and Elasticstack, which are closely related, and I'm the owner of another one, Drone CI. If you want to go deeper into a topic or you want to discuss more about today's topic, feel free to reach me out to the email, Twitter, or whatever you prefer. So the agenda for today will be divided into two main parts. So there are 4 sections, but 2 main parts. The first part is about an introduction of the software. So we said Bazel and Telepresence. The second part is more about how they interact with each other, how they combine, and we will see some examples. So at the end of every section, there is a demo, so that you will not just get bored with all the slides and everything, and I hope you're going to enjoy this. So, first question, how many of you have ever heard or used Bazel before? Raise your hands. Okay, I see some people. And that's really good also because Bazel is used to build Kubernetes itself, and TensorFlow as well. It comes from an internal project by Google. TensorFlow and Kubernetes come as well, so this is not really surprising. What is Bazel is a build automation tool. So something that is very close, it's CMake and make. I'm pretty sure all of you are familiar with that. So it works kind of in a similar way, but it's much, much more powerful than these tools. It allows features like parallel execution, incremental build, reproducible builds, hermetic builds, and we will see more of these features during the presentation. Second question is, how many of you have heard or ever used Telepresence before? All right. So Telepresence is a two-way communication proxy for Kubernetes. It works in a kind of similar way as kubectl pour forward, but it's much, much more powerful than that. And during this presentation, we are going to go into deep details of how it works and what enables you. All right? So we are going to start with Bazel, a reproducible build. Why do you need reproducible builds? How does it help you? Why is it necessary? Well, to understand what is reproducible builds and why do we need them, we need first to understand the architecture that people use, how they build their software, how you all build your software. And we're going to analyze 3 main architecture for this. So the first one is the standard architecture, which is pretty much like no architecture. It's taking all the software and installing on your machine, whether it's Java, it's Golang, it's Node.js, and hope that this will work. So there is going to be very huge guidelines, README, on how to make it work. Most of the time it will just not work. Your newcomers are going to scream because this is hell for most of us, and I know that many of you know that. So how many of you are currently developing this way? I would like to know your hands. Don't be ashamed, just raise your hands. Okay, this is really good. There is not too many hands. So this is very bad architecture, also because when you need to make something up and running, it doesn't work out of the box. You just cannot check out the repository and make it work. So we are going with the next kind of architecture, one that has become more and more popular nowadays, which is the containerized architecture. So Your building environment, it's inside a Docker container. So if you need to build Golang, it will be the Golang toolchain. If it's Java, it's the SDK of Java, and so on and so forth for all the programming languages that you are currently using. How many of you are using this one instead? Oh, that's surprising. So this is good, but there is still something that can go better. Because what is the problem with this kind of architecture? Well, when you build something with Docker, well, if you build it now and if you build it in 1 week and 1 month, it's going to be different. The output is different because Docker doesn't come with the promise that what is going to be delivered, what is the output, is actually the same. It just doesn't give you this promise. So we are going to look at Bazel, because Bazel instead gives you this kind of promise, this kind of guarantee. You build something now, you build it in 1 week, you build it in 1 month, it's always the same output. It doesn't matter where, how, or when you build it, the output doesn't change. It's simply almost the same. And this gives you reliability, because in order to something to be reliable, it must be always the same output. You must know what you're producing. And so for big, large platforms or for critical application, this is necessary. So just as a summary, reproducible builds means that every output is always the same, and hermetic builds means that it doesn't interact with the surrounding. It doesn't matter what you have installed in your machine. It doesn't matter what's installed in your container. There will be no difference whatsoever in the output of the binary itself, right? So we are gonna see some example of this. I'm gonna run 3 commands. The first 2 commands were related to Golang. Those are all Bazel commands. The first 2, I could have run them before, but I would like to show you how Bazel actually works. The third command is just building the application itself. So I'm gonna hope that this, yes, you can see. All right, so this is the first command. And I'm gonna build it here. Whoops, I didn't open it from here. Terminal, make it bigger. So what Bazel is currently doing now is generating this file. You can see it here, a new file has been generated. So this file simply tells Bazel what we are building, which is a Golang application, and we are using just a simple file. It's just one single source file. And I'm gonna show you immediately. So this is very, very basic. We are just gonna print the environment variable. The second part is just to include an external dependency. And we'll see in one moment why I wanted to include an external dependency. So the second command is this one. All right, that was fast. And one file has been changed. A new bunch of lines have been added. Why is this necessary? Because Bazel is language agnostic, which means that Bazel doesn't care which language are you building. It's just simply not aware of the language itself. So this simply tells Bazel that we are gonna need an external dependency, and is grabbing this dependency from the package manager of Golang. And the other command is, well, as we said before, it's just building the image. And that's it. We built the application. And this is a reproducible application, because we said before that Bazel comes with a promise, and this promise is to be always reproducible and hermetic. So we're gonna move forward to the second software that we introduced before, Telepresence. So what is Telepresence? We said before that it's a two-way communication proxy, but what does it proxy? Because there is many things that Telepresence does, and the first one is internal resources, which means that everything that is available inside your cloud, is available on your laptop as well once you launch Telepresence, because it will be proxied. It means that you can use internal IP addresses and you can use internal host names. So this makes available from within your machine, for example, instances, SQL instances if you need them. It's going to make available, for example, other microservices that are running in your cluster that are discoverable from your cluster, or PubSub and so on and so forth. So this is the first feature, the first nice feature. You don't need to set up kubectl performer for this because Telepresence will do it for you. The second feature is volumes. Telepresence makes available all the volumes that are mounted into your deployment to your machine. It uses a network file system and it makes everything available, which means that if you want to use secrets that are mounted as volumes, you can do that without saving the file in your repository, in your laptop, in some obscure path. You can just access it. And the third one is my favorite one. Environment variables. So when you have a deployment, most of the time, I would say 99% of the time, you have some kind of environment variables. And this will be proxied directly to your machine, which means it will be available to your application. So every secret, every configuration that you need, it will be directly available to your application. This means that you no longer need the YAML file, the typical local YAML files, the JSON file, or whatever local configuration you need, because you can simply use Telepresence and get the environment variables directly from the cluster. But how does Telepresence do it? Because there is different way that Telepresence do it. And we're gonna quickly run through all of them, and I will explain which one are we gonna use. So the first one is the VPN tunnel. So it just creates a simple VPN tunnels. It affects all the processes that are running on your machine, which might end up in some kind of unexpected behavior. So it's like, yeah, okay-ish, I would say. And, well, it doesn't work with other VPNs. If you have an Office VPN, this method is just not going to work because it's going to clash the VPN that you have for your Office with the VPN set up by Telepresence. So the next method is the TCP injection. Maybe some of you are familiar with this kind of approach. It simply loads a library beforehand, so all the calls that are made to try to resolve a host name will first go through Telepresence. This has some drawbacks because, if for example, it doesn't work with statically linked binaries, and well, if you're using a custom DNS resolution, it will not work well. So the last one is my favorite one, and it's the one that we are going to use through this presentation in the future slides, is the container mode. So basically, you're launching a container, and all the traffic incoming and outgoing from your Docker container will be proxied through Telepresence. So this is nice because it affects only one single process. You can use your Office VPN and you can use Docker. So we have everything in one single mode. And also of this, as I said before, we're gonna see one simple demo. I will not run all of them because unfortunately we have some time constraints here, but I will run the first command, which is the Telepresence without any built-in arguments. And I will show you what we can do with Telepresence. Okay. So what I'm connecting to right now is this cluster inside the Google Cloud Platform. There is just one single instance running. It's a demo application. It's basically just an Nginx server serving the response hello world. There is nothing very special about that. But we are going to see why this is so nice to have there and what we can do with that. So Telepresence is asking for my password. And now it's connecting. So it's setting up a new deployment here. So I'm going to refresh. And you can see that it started a new deployment. This deployment is responsible for the proxy. So this will be the proxy inside our cluster. And here, now we have the command line. So I'm gonna just print the environment variables and filter out whatever is related to the demo application. And as you can see, the output that we got is coming from Kubernetes because this is what Kubernetes provides by default, which is the IP address of the demo application. So we are gonna just send a simple request to this service. And this is going to be using the internal IP address. Normally, you wouldn't be able to connect to that, but Telepresence makes it possible to actually connect. And here we go, hello world. We are gonna try also to use the internal hostname, demo app.default, which is not really necessary, but just to show as a purpose that you can use the namespace as well. So we were actually able to connect to something that is internal to the cluster itself, and this is thanks to Telepresence. I'm gonna exit this demo, and as you can see, the cleanup process has started, which means that it will delete in a few seconds from here the actually Telepresence deployment. So going further with the presentation, the next section is the containerized development environment. So what is a containerized development environment? We said before that there are different kinds of architecture where people can build their software. But let's bring this further. Let's do another step with this kind of architecture. How many of you are using this one? No isolation for both execution and compilation. So you are executing and building everything just on your machine. No container, no nothing. Just raise your hand. Okay, not so many. That's interesting. So this brings a lot of problems. This brings a lot of problems because what you're building, what you're running is interacting actively with the host machine. And this creates a lot of conflicts. This creates a lot of environments or a lot of problems that you don't know how to solve, and you have no clue where they came from because your computer is set up in a different way from your coworker. So this leads to the typical, it works on my machine, and it doesn't work to the others. So the second kind of architecture, the second kind of environment is building and executing inside Docker. So you have isolation for both execution and for both compilation. How many of you are familiar or are currently actively using this kind of architecture? Whoa, that's a lot of hands. This is really good. This is really nice. This brings a lot of good features because, as we said before, if we isolate from the surrounding environment, from the surrounding host system, we are avoiding problems like it's not working somewhere for some obscure reason, or simply it just works out of the box. You can check out the repository and it will work. Your coworker will be able to run your software, compile your software just by checking out your repository. And the next one, well, it's simply use reproducible environment. As we said before, reproducible is good. Reproducible builds brings a lot of reliability. It's a good feature to have, and it's very important if you are working with large applications or with critical ones. So we are just using Bazel here. So we are containerizing Bazel itself, and we are using Bazel to make sure that what we are producing is something actually reproducible. All right? So we are gonna simply build a Docker image for Bazel. So it's very basic, and I'm not gonna run the first command because otherwise it's gonna take too long to download all the layers for the image, but I'm gonna run this other two, just to give an example. So this is the Docker file. It's less than 20 lines. It doesn't take much to actually containerize your building environment. And Bazel, it's even easier. You can find thousands of these kind of images that are already ready to be used. So I'm just gonna build this and run it. And the command comes from here. All right. So that was very fast because, of course, on my machine is already built, so it's already available in the local image registry. And I'm going to run it just to show how Bazel works. And, well, it simply prints out the version because, as we can see from the Docker file, that's the default command. It's the version command. So run local containerized application in the cloud. This is the next section. But before we go into this, I want to highlight something from the previous slide, which is there is some yellow line. So up to here, we try always to get everything green. But here, there is something yellow. There is Docker Compose, which is okay. But why is it okay? So Docker Compose is one of my favorite tools. It's so easy and so simple and takes away so much burden from you. So you are developing, for example, a microservice. You need to run an SQL instance. It's very easy. But then, what is the problem? Well, the problem is that at some point, your architecture might grow and it might become very complex. And this is where things start to get nasty because, for example, in our company, we have this synchronization service which have to connect to multiple microservices, multiple legacy systems. It has to use many services, and I can simply not emulate everything on my machine. I have just too many services that I need to emulate. So what are we going to do? How are we going to solve this problem? Well, we are using Telepresence. We will be using Telepresence, and we will be feeding the image that we generated with Bazel to Telepresence. So we're going to have reproducible build, which comes from Bazel, because we said builds from Bazel are reproducible, and we are generating distroless images of Bazel. So what is a distroless image? Distroless images, well, normally when you build something with Docker, you use the first line is from, and you're selecting a distro. Ubuntu, Alpine, Debian, whatever. The problem is that by using a distro, things start to get difficult to reproduce. So what Bazel does is create this new kind of images. They do not contain any distro. So they contain literally two things, which are the application itself and the runtime for that application. There is nothing else, not even the shell. There is nothing inside these images. They are completely distroless. And going back to the main topic, we said that Bazel creates reproducible builds. And these reproducible builds can include images which are reproducible also. And this gives us this reproducible development environment, which is the first part of the title. This is the first part of what we wanted to achieve. So by fitting this kind of images to Telepresence, by using Telepresence as a proxy, we are creating a reproducible deployment. What does it mean, reproducible deployment? Well, simply speaking, what you're using with Docker Compose is a fake environment. It's not a real environment. It doesn't emulate. It will never be able to actually emulate the real cloud, what you have inside the cloud. With Telepresence, you are actually accessing real resources, which means that what you're building on your laptop and what you are deploying from your laptop inside the cloud, inside your cluster in Kubernetes, will be exactly the same as your pipeline will build inside the pipeline and deploy inside the cloud. There will be no difference in the services used and in the application itself. Everything will be exactly the same. So here is a short recap of what we have seen so far. We've seen why isolation is important. We saw why something being reproducible is very important when you have critical or large projects. And we are going to see now the last demo. So the last demo, we are going to just run two simple commands. The first one is, well, Bazel generates images without the Docker runtime. So Docker is not aware of where the image is. So Bazel doesn't know about the image. Docker doesn't know about the image. So by running the first command, we are making Docker aware that there is an image, and we are loading this image into the local registry. The second command is well, the container mode for this image inside the cloud, inside our cluster. And as we have seen before, if you remember, this application will just print environment variables. It doesn't do much. It's very simple. So the first command we run against this few lines here. So this will just tell Docker, please load this image inside the local registry and use this tag. And I'm gonna run it immediately because we are running out of time. So you can see the output, the checksum, and the tag of the image itself. And now that it's loaded, we can run the last command, which is this one. Telepresence container mode using the image that we just generated. Takes a little to load everything up, because Telepresence has to start a new pod, so it takes a few seconds, but it will be running, yeah. Okay, so we got the output. As you can see from the output, this is not the environment variables of my laptop. This is environment variables coming from Kubernetes. So the application itself, it's not aware that it's running on my laptop. It thinks that it's actually running inside the cloud, which is very important because this gives us this reproducible deployment that we wanted. So going back here, what is the conclusion? What is the outcome from all of this? Once we are able to use telepresence in container mode with a reproducible image, what is the conclusion from this? Well, the conclusion is that there will be virtually no difference between your local deployment and a remote deployment. The image is the same, the application is the same, and the resources are the same. So this is what we wanted, and this is what this presentation wanted to achieve. So if you have any question, now is the question and answer moment. Otherwise, there is some more jokes that you can read on the screen. I hope you enjoyed this.
So is it still true that using telepresence, you swap out one deployment on the cluster for everybody? So if you as a developer use telepresence, everybody else will see your local
yes.
service running in the cluster? How can that be solved easily, other than using a cluster for every developer?
That's a tricky question. So the question was basically, if I use the swap deployment, so if I take over a deployment, of course, one developer is going to take over the deployment from everyone else, so nobody is going to be able to develop. Well, I would say that one solution to this kind of problem is to use multiple namespaces in your development environment, so different developers are using different namespaces. This way, you can take over your own deployments without disrupting the service for someone else. Or otherwise, I think you need to take more and more complex architecture than this. Yeah, there is no easy way around this, but maybe you will be able to get a better answer by DataWire itself, by the creators of this product, because they are here at the KubeCon, so you will be able to directly ask them. My personal suggestion is to actually use a namespace for each developer. Any other question?
Hi. Yeah, so how do you actually see the changes that you made locally?
Sorry?
How do you actually see if you make changes to the code that you're developing? How are they reflected remotely? Do you need to execute some commands, recompile? What's the workflow, or less?
So the changes on the deployment?
Yeah. Well, you basically are setting up the proxy so it will see the code that you have locally, and then you make some changes. Let's say you change some assets of your application or some code. Then how is that then, how do you see it? Do you have to recompile? Do you have to?
So the question is, if you want to see some changes in, like for example, the traffic, or so you are taking over a deployment that has traffic inside, and you want to see some changes. This is the question about.
Let's say you are making a website and you change some of the HTML. Then how do you actually see it reloaded?
Can you rephrase the question, because I'm really having a hard time understanding.
Okay, so let's say you're making you have an API and you change the format of the response locally.
Yes.
How is that going to be visible in the cluster?
Oh, okay. Now it's very clear, the question. So basically, when you are swapping and taking over the deployment itself, well, first I can run it right now. So there is just the demo application. I'm gonna run the command from here. So this is gonna swap the deployment and actually take over the deployment. This takes a while. All right. So the first thing is that, well, other developers will be able to see that a new deployment has been created. So this is the first signal that someone is taking over an existing deployment. And how you will be able to see the actual changes is that now all the traffic that is being sent to this deployment, so to the original application, once you take over, all the traffic that goes to this deployment will now come to your laptop, which means that if there is an application running, the output, what will be the response coming from your machine, not from the cloud anymore. If you do not run anything, so if you just swap deployment, like in this case, and you do not run any other service, any other web server, well, if anyone tries to connect to this application and send some traffic, they will just go into timeout because there is nothing listening to this application. So this is how it actually works. Sorry, I had such an hard time to understand. Any other question? Okay.
So I love the containerized build thing. One issue that I've run into with it is developers on Macs, they're usually running Docker in a VM and building, say, large amounts of native code or anything that's heavy. Basically, everyone's laptop just kind of lights on fire. Is that an issue you've had to deal with at all with, like, so you're running Bazel in Docker? And if so, how have you dealt with it?
So your question is whether it is a good idea to do this kind of approach for all the applications, right? Yeah. So
specifically the build portion.
So the one that you are talking about, I guess, is it's going to be this one.
Yeah, source code is built from Bazel inside a container. That's something that I've seen is like kind of heavy on a MacBook, for example.
Using Bazel inside a container, whether this is a good idea. Well, yeah. We had a case in our company where there was a Windows user that was using Bazel on her own laptop. And the problem is that Bazel is not so easy to install on Windows. It takes a very, very long steps. There is a lot of debugging. It's not really ready for Windows. It works a lot better with Linux and Mac OS. So containerizing Bazel itself allowed us to use just Docker, and Docker on Windows, you install it with the installer, it just takes a few seconds. So this helps people to be able to be up and ready as soon as they check out the repository. So of course you can use Bazel without using Docker, but you are going to encounter at some point like a different version. This is also another problem. People using different version of Bazel will lead up to different output or just to not be able to compile. By using a Docker image, you are ensuring that whoever is building is using the correct version of Bazel. Okay?
Thanks.
Perfect.
For the hot swap you just showed on the demo app.
Sorry?
For the swap you showed on the demo app earlier with a question of this guy. You showed.
Okay, the swap deployments, yeah.
This will swap the demo app for everyone, or just
yes.
Yes.
This is going to swap for everyone. So this is actually one of the question that was already asked. And so basically, the problem is that, of course, if multiple people are working in the same environment, so if you have one single namespace and one single cluster where multiple developers are working, this is not going to be easy because once you take off deployment, you are doing that for everyone. So you are affecting everyone.
Yeah, okay. I wasn't sure, but thank you.
Okay.
So when you do the swap deployment, is that now locked to you? Can someone swap deployment your swap deployment? Like, when you do that, the swap deployment, is that now reserved for you? Does Telepresence keep track that you're now using it? Or can someone else do a swap deployment on my swap deployment?
That's a good question. I never tried that, so I'm not actually sure what happens if someone tries to swap my own deployment. This would be funny. I guess that Telepresence actually would swap the deployment itself, so there will be a swapping, and go into exception, and I don't know. I'm not sure how to answer to this because we never tried. We try to work on our application into our own namespaces, or there is not too many developers, so we can tell all the developers when we are developing something and we are taking over a deployment. So if there is no other question, I have some free t-shirt for, I know that everyone loves free t-shirts, so you can just come and grab one. So